Hello, class, and welcome to Chapter 3. We're going to be covering common network topologies and infrastructures. Here are a few of the topics that we'll be covering. Network topology refers to the arrangement of elements within a communication network. This includes how computers, servers, and other devices are interconnected. The physical layout directly impacts the communication methods, hardware required, and even the network's redundancy capabilities. Understanding the various types of network topologies helps ensure that the right design is chosen to meet an organization's goals, whether those involve performance, reliability, or cost efficiency. Hubs are basic network devices that aggregate physical connections, but they are considered dumb because they lack intelligence in managing traffic. A smart hub or repeater can amplify and rebuild signals, helping maintain network efficiency. Switches operate at layer 2 using MAC addresses to direct traffic, while routers work at layer 3 and are responsible for forwarding data packets across different networks. Routers often sit at the boundary between a LAN and the internet. Devices like bridges and routers serve specialized purposes, such as connecting two different segments or acting as both a bridge and router. Gateways, meanwhile, convert communication protocols between disparate networks. Here's a diagram showing the placement of these devices in a typical network. Physical topology describes the actual connections, wires, cables, or wireless signals between network devices, while logical topology refers to how data flows through the network, often controlled by software configurations like VLANs or subnets. Wired topologies include physical cabling like internet, while wireless topologies rely on radio frequencies or infrared signals for connectivity. Logical networks can span across multiple physical layouts, offering greater flexibility in resource management and security control. A bus topology is simple and linear, with all devices connected to a single cable, but its simplicity often leads to performance issues as the network grows. Ring topology connects each device to its neighbor, forming a closed loop. Unidirectional rings send data one way, while bidirectional rings offer redundancy by sending data in two directions. Star topology uses a central hub, offering improved performance and fault tolerance because a failure in one connection doesn't disrupt the whole network. Mesh topology, often used in mission critical environments, ensures high availability by connecting every device to multiple others. Hardware failures, such as hard drive crashes, are among the most common causes of unexpected downtime in IT infrastructures. Organizations can mitigate these risks by implementing regular backups, using RAID configurations, and maintaining spare parts. Intentional electromagnetic interference is a physical threat that can damage or destroy electronic equipment. This type of attack can target anything from cell phones to servers, disrupting communications and operations. Theft, physical damage, and natural disasters also pose significant risks to IT infrastructures. Organizations should prepare for these threats by securing physical assets, implementing disaster recovery plans, and strong backups off-site. Here's a graphic comparing the pros and cons of each topology type. IP version 4, the protocol that has been the backbone of the internet for 30 years, is a 32-bit addressing system with around 4.3 billion possible addresses. However, due to the explosive growth of connected devices, the available address pool has become exhausted. IP version 6, with its 128-bit addressing, offers an exponentially larger address space. It also provides improved security features like mandatory IPsec and simplified address management with built-in auto configuration. Organizations transitioning from IP version 4 to IP version 6 had three main options: dual stack systems, which is using both protocols simultaneously; tunneling, which is sending IP version 6 packets over an IP version 4 network; and protocol translation, which is allowing IP version 4 and IP version 6 devices to communicate. A work group is a peer to peer network where each device has equal authority, often used in small environments with fewer than 10 computers. In contrast, client server networks centralize control, offering better security and resource management. Local area networks operate within a limited geographic area, typically owned by a single organization. Wide area networks span greater distances and often rely on external service providers for connectivity between locations. SOHO, which is small office home office, networks are commonly found in small businesses and present unique security challenges, such as limited resources for deploying enterprise level protection. Here's a figure that shows a LAN versus a WAN setup. Segmentation is one of the most effective security strategies for protecting sensitive information. By isolating certain parts of the network, organizations can minimize the attack surface and limit lateral movement in the event of a breach. Firewalls, intrusion detection and intrusion prevention systems, and DMZs provide essential layers of defense. Firewalls control traffic entering and leaving the network, while intrusion detection and intrusion prevention systems detect and prevent malicious activity. DMZs isolate public facing servers like web servers from internal resources. Networks are only as strong as their weakest link, and improper configurations or a lack of redundancy can expose critical vulnerabilities. Regular audits and updates are crucial to maintaining a secure infrastructure. In this chapter, we have covered why understanding network topologies is fundamental to designing efficient and secure networks. As businesses grow and new devices are introduced, choosing the right topology becomes increasingly important for performance and security. And that concludes this presentation, and thank you for watching.